students, in our last lecture we have discussed how to solve the system of linear equations by reduction method. In that lecture we have studied how to find out the solution of pair of linear equations in two variables. Today we are going to discuss how to solve the solution, how to find out the solution of three linear equations in three variables. So let us see. The question is, solve the following equations by the method of reduction. Suppose three equations are given to you like this. First equation is x plus 2y plus z is equal to 8. Then 2x plus 3y minus z is equal to 11. And 3x minus y minus 2z is equal to 5. These are the three linear equations with three variables x, y, z, and we have to find out the values of x, y, z by using method of reduction. So first of all, as we know that the given equations can be written in matrix form as Ax is equal to B, where A is the matrix which is formed by the coefficients of x, y, z respectively. That is, here see 1, 2, 1, then 2, 3, minus 1, and then 3, minus 1, minus 2. Then x is the column matrix of three variables x, y, z, and B is the matrix which is of constants on the right hand side of the equation. That is, here 8, 11 and 5. So let us solve this by using reduction method. So we write the given equations in matrix form like this. Now as we know that we have to convert this matrix A into an upper triangular matrix or lower triangular matrix, but we prefer upper triangular matrix. So in case of 3 by 3 matrix, here we required 0, then we required 0, and then here we required 0. And to get these three zeros, we will perform suitable row transformations on both sides. Okay, so use the suitable row transformations so that we get 0 here, then we get 0, and then here 0. But first of all, in the first row, we required first element as 1. Now it is already there is 1. So it is very easy to convert this 2 as 0 and this 3 as 0. So see, if you perform this transformation, that is R2 changes to R2 minus 2R1. Okay, then you will get 0 here. Similarly, simultaneous transformation if we take, that is R3 changes to R3 minus 3R1. So here we get 0. So simultaneously we will do these two transformations. Then what will you get? See here. First of all, think about the second row, that is R2 minus 2R1. So here obviously we get 0. Then this is 3 minus 2 times 2. So 3 minus 4, that is minus 1. See carefully. Then minus 1 minus 2 becomes minus 3. X, Y, Z as it is equal to, on the right hand side, this is 11. 11 minus 2 times R1 means 2 times 8. So 11 minus 16, that is minus 5. Okay. So second row is completed. Now third row, as per this, it is R3 minus 3R1. So 3 minus 3 will get 0. Then this is minus 1 and minus 3 into 2, that is minus 6. So minus 7. We get minus 1 minus 6, that is minus 7. And here it is minus 2 and minus 3 becomes minus 5. Okay. Now on the right hand side, originally this is 5. 5 minus 3 times 8. So 5 minus 24, that is minus 19. So here we get 0 as well as here we get 0. Now we required 0 here. Okay, so again we have to change the row number 3 by taking suitable transformation. Now for that we required second row. Then how will you use the second row? If you think carefully, then you observe that R3 minus 7R2 gives 0 here, because minus 7 plus 7 becomes 0. So here we have to multiply with minus 7. Minus 7 into minus 1 becomes plus 1. So minus 7 plus 7 becomes 0. So see here. So first row as it is, second row as it is, and in the third row here 0 remains 0 as it is. Now minus 7 and this is plus 7 becomes 0. Now minus 5 and so minus 7 into minus 3, so plus 21. So minus 5 plus 21, that is 16. And here in the third row, in this case this is the third row, that is minus 19. Minus 19 plus 35, minus 19 plus 35, check this, we get 16. So this is the upper triangular matrix. Okay, after getting this and this one as a 0, we convert this original matrix into an upper triangular matrix. Now if you rewrite this matrix form into the regular form of the equation, then we get, what will you get? First equation, if you actual multiply this first row into first column, then you will get x plus 2y plus z is equal to 8 as a first equation. Then see this, if you multiply second row into this column, then 0x minus y minus 3z is equal to minus 5. See here carefully. And third equation as 0x plus 0y plus 16z is equal to 16. So if you observe these three equations carefully, it is formed by this matrix form. Okay. Now what happens after getting these three equations? If you observe the third equation, then from equation number 3 we get 16z is equal to 16, and hence directly we get the value of z is equal to 1. Now if you use, or if you put z is equal to 1 in equation number 2, then what happens? See here, we get this, put z is equal to 1 in equation number 2, then minus y minus 3 into 1, that is equal to minus 5, and after solving we get minus y is equal to minus 2, and hence y is equal to 2. Just by regular way, if you get value of z is equal to 1, then use the equation number 2 to get the value of y as equal to 2, and then finally by using equation number 1 like this, so x plus 2 into 2 plus value of z is 1, that is equal to 8, and solving this we get x plus 5 is equal to 8, and hence x is equal to 3. So if you perform the row transformation to convert the given coefficient matrix into an upper triangular matrix, we can solve the given equations very easily like this, and hence we get the final answer as x is equal to 3, y is equal to 2, and z is equal to 1. You can verify this answer by substituting value of x is equal to 3, y is equal to 2, and z is equal to 1 in all three equations. Okay, check your answer. So this is the method of reduction to get the solution of three linear equations. Okay, now we will solve another example. Suppose these three equations are given to you. X minus y plus z is equal to 4, then 2x plus y minus 3z is equal to 0, and x plus y plus z is equal to 2. Okay, again by same technique we will write the given equation in the form of matrix, that is ax is equal to b, where a is equal to, check this, 1 minus 1 1, that is from this first equation, then 2 1 minus 3 from second equation, and 1 1 1 from third equation. Then x is equal to xyz, b is equal to this matrix 4 0 2, which is of constants on the right hand side. Again we have to convert this into matrix form, means this is called as matrix equation, and by suitable row transformation we have to convert this matrix into an upper triangular matrix. So if you observe here, then there is 1 here, so it is easy to convert 0, then this 0 and this one as 0. So if you perform this transformation, that is R2 changes to R2 minus 2R1, then you will get 0 here. Similarly, if you subtract first row from the row number 3, then 1 minus 1 becomes 0 here. Okay, so what will you get? See, first row as it is. Now just see the second row. This is 2 minus 2, we get 0. Then 1 minus minus plus 1 into minus 2 into minus 1, that is plus 2. So 1 plus 2 becomes 3 here. Now this is minus 3 minus 2, that is minus 5. Okay, on the right hand side what happened? See, this is 0 minus 2 times 4, so 0 minus 8, that is minus 8. Okay, so we completed the second row by using this transformation. Now apply the transformation on third row, that is R3 minus R1, that is 1 minus 1, we get 0, then 1 minus minus plus 1, that is 2, and 1 minus 1, here we get 0. Okay, then here it is 2 and 2 minus 4, that is minus 2. Okay, now actual method is what? We have to convert the given matrix of coefficient into an upper triangular matrix to get the solution. But if you observe this, after getting this 0 and this one as 0, at that time we get 0 also here, and without converting 0 this 0, okay, we get the solution of this linear equations. Okay, because we have converted this as a 0, also here we get simultaneously 0. That's why after getting this one as 0 and this one as 0, we can solve these equations. Okay, so if you convert directly this equation into the regular form of the equation, then what will you get? We get, see, first equation as, if you multiply first row into first column, then we get x minus y plus z is equal to 4, that is the first equation. Then if you multiply the second row with this column, then we get 0x plus 3y minus 5z is equal to minus 8 as a second equation. And what about third equation? See here, if you multiply the third row into this column, then we get 0x plus 2y plus 0z is equal to minus 2. But see, we haven't converted this matrix into an upper triangular matrix. This is not an upper triangular matrix, but still we have this equation 0x plus 2y plus 0z is equal to minus 2, by which we get the value of y. So it is not necessary to convert the equation into the matrix into an upper triangular matrix. If you get the answer of any variable first, means no problem that we don't have the answer of z, but here we get the value of y from the equation number 3. So you can stop your procedure. So from the third equation directly we get the value of y, that is y is equal to minus 1, because 2y is equal to minus 2, that is equal to y is equal to minus 1. Okay, so this is very important, because our target is what? We have to find out the value of x, y, z. So after these two transformations, if you get this form, then it is not necessary to convert the given coefficient of matrix into an upper triangular matrix. Without that also we get the value of y, and as we get the value of y, and if you put the value of y is equal to minus 1 in equation number 2, then you will get the value of z also. So what is that? See here, if you observe this, then by calculating we get z is equal to 1. Okay, and if you put value of y is equal to -1 and z is equal to 1 in equation number 1, then from equation number 1 you will get, observe this, we get value of x is equal to 2, because this is x plus 1 plus 1, that is x plus 2 is equal to 4, and hence x is equal to 2. So hence we get the answer as x is equal to 2, y is equal to -1 and z is equal to 1. So this is very special example, that is our main target is to get the value of x, y, z by using reduction method. So it is not compulsory to convert the every coefficient of matrix into an upper triangular matrix. If you get 0 here and 0 here, then you will get the value of one variable, any one variable, then you can solve like this also. Okay, so this is very important question, remember this. Now we will discuss another question. Suppose the equation is given x plus y plus z is equal to 1, then 2x plus 3y plus 2z is equal to 2, and x plus y plus 2z is equal to 4. Then these three equations can be written in matrix form as Ax is equal to b, where A is this matrix, see here 1 1 1, then 2 3 2 and 1 1 2. Then this is x and b is 1 2 4. Okay, so this is the matrix equation. Now here there is 1, so easy to convert this 0 and this one as 0. Now if you perform the operation, that is R2 changes to R2 minus 2R1, and simultaneously if you observe, then R3 changes to R3 minus R1, then what will you get? See here, see 2, see the second row only, 2 minus 2 we get 0, then this is 3 minus 2, because 2 into R1, so 3 minus 2 becomes 1, then 2 minus 2 will get 0 here. Okay, and then R3 minus R1, so 1 minus 1 0, here it is 1 minus 1, again we get 0, then 2 minus 1 we get 1, and on the right hand side observe here, this is 2 minus 2 will get 0 here, and 4 minus 1 we get 3 here. Perform same operation on right hand side. Now if you observe this equation, then here this is 0, this is 0, and this is also 0. Now while getting 0 here, we get 0 also here. Okay, so our procedure is completed. We get the upper triangular matrix. Okay, so procedure is completed after these two transformations. So if you convert this into the regular form of equation, then we get the first equation as x plus y plus z is equal to 1. Then observe the second equation, it is 0x plus y plus 0z is equal to 0. Okay, and third equation is 0x plus 0y plus 1 into z is equal to 3. Now but from equation number 3 we get the value of z is equal to 3 directly. See here, observe the equation number 3, then we get z is equal to 3, and from second equation directly you will get the value of y is equal to 0, because we have remove x and remove z also due to this 0 and this 0. Okay, so directly we get y is equal to 0, because on the right hand side that is 0. So it is very easy. So if you put all these values, that is value of y at 0 and value of z is equal to 3 in equation number 1, then we get the value of x is equal to -2, and hence our final answer is x is equal to -2, y is equal to 0, and z is equal to 3. So the reduction method is very useful to get the solutions of two linear equations as well as three linear equations. So this is the all about method of reduction. So always our procedure is what? We have to write the coefficient matrix, we have to convert the given equations into the matrix form, and try to perform the row transformation so that we will get or we will convert the given matrix of coefficient into an upper triangular matrix, and our main aim is to get the values of x, y, or in case of three equations we require the values of x, y and z also. Okay, so this is the all about information about the reduction method. We will solve more questions related to this method, or also we have solved the given equations by using inversion method also. But if you compare the both the methods, inversion as well as reduction method, the reduction method is quite easy method. Okay, so practice for it. Thank you.